You all know it is very important for the store managers to give a very good services to the customers who are coming in. The customer should not have to wait a lot of time in the store. They should get the product. They should get the products they're requesting for immediately. So here we'll look at the use case of managing these customer services efficiently using again the concepts of distribution. What is the use case? The use case is here again in the Adventure Works store. There's 16 customers that arrive to the cashier per hour. Using the historical data, they know that every hour at least 16 customers arrive at this cashier. And based on the again historical data, it is seen that a constant 6 minutes of time is taken to process each of the requests. Then the store manager has put up 3 cashiers. So 3 people would be serviced simultaneously in 6 minutes duration. What the store manager is interested in knowing is there a need for 4th cashier, or can he reduce the cashier? Because he does not want customers to wait. He can keep on adding the cashiers, but that will not that might result in inefficient usage of the cashiers, because if there are less customers, the cashiers may sit idle. So he wants to see if 3 is an apt number, and is there a probability that 1 or more customers will have to wait in this 6 minutes duration. How do we solve this use case? This use case is a typical use case of Poisson distribution, because here we are considering the time interval between events. The time interval here is 6 minutes, which is 0.1 hour. So what is the value for lambda? 16 customers arriving in 0.1 hour, which is 1.6. What is the number of customers that checked out in this time duration? 3 customers. So the customers that will have to wait in the 6 minutes duration would be if there is a 4th customer, or a 5th, or a 6th, or a 7th, and so on and so forth. So basically a cumulative probability of 4 plus 5 plus probability of 6, and so on and so forth, which is nothing but a probability 1 minus the probability of less than 3 customers arriving. How do we calculate the probability of less than 3 customers arriving? We use a Poisson distribution formula, where the first parameter is the number of customers, which is in this case is 3. The second parameter is the mean value, which in this case is 1.6. And then again we use the true as the parameter, which results in the value of 0.92. But we were interested in the value of 1 minus this Poisson distribution value, which is the cumulative mass function value. What happens? What is the probability of at least 1 customer that will have to wait for more than 6 minutes is 1 minus 0.92, which is 0.078. Again, this probability is very, very low, and we are assured that there is a very low probability that the customers will have to wait during that 6 minutes period of their checkout. This brings us to the last use case for this session, which is again based on the customer servicing time. We looked at an example of Poisson distribution, and now here the use case is slightly different. Here, Adventure Works also has a snacks bar where they serve 30 people on the weekends in an hour of duration. Now, when people arrive and take a product from the refrigerator, it takes about 1 minute for the store employee to fill the refrigerator. The store manager wants to know the probability of 2 successive customers arriving in less than 1 minute. If they arrive in less than 1 minute, they probably would have to wait for the product in the refrigerator. So the store manager wants to know if 2 people will arrive in less than 1 minute. Now, if the number of events per unit time followed a Poisson distribution, the amount of time between 2 different events will follow exponential distribution. So here we have the information that arrival rate is 30 customers per hour, which is 0.5 minute. The time between 2 successive customer visits is 2 minutes. So the decay rate would be lambda is equal to 1 by 2 is equal to 0.5. Now the random variable x in the duration between the arrival of customers, then and we have if this is a random variable and we have to find the probability of x less than 1 minute. So the cumulative density function will give us this probability, which is f of x less than 1, and the formula for exponential distribution is 1 minus e to the power of minus lambda x, which if we replace the value gives us 0.395, which is approximately 0.4. So the probability that 1 or more customer that arrive in less than 1 minute would be 40%, which is considerable, and the store manager should take actions accordingly. I hope these 3 examples give you good application of binomial distribution, Poisson distribution, and exponential distribution. Similarly, these distributions can be applied to other use cases as well. That's all from my end. Thank you so much for listening in.